Hello everyone, today we're going to be talking about 2D lists, also known as 2D arrays. So before we get into 2D lists, let's do a quick review for lists, because to understand 2D lists you have to make sure that your understanding of lists is pretty good and that they're pretty fresh in your mind. So let's just review them really quickly. So lists are just an ordered collection of objects. What this means is that it's a collection obviously, but every member of that collection has an order. The first thing you put into a list will always be the first thing until you change it. So if you put 1, 2, 3 things into a list, the order of the things is going to be retained, and the way you check the ordering, or make use of the ordering rather, is through the indices. Now lists allow modification. You can change something that's in a list, take stuff out, add more stuff in it, change the stuff that's within. So lists allow modifications. Some other types of collections do not. Now, a cool thing about lists is that they're very generic in what they accept. They just accept objects of any type. So lists do allow members to be of different types within a single list. So you can have a list that has a number, a string, a boolean, a bunch of different stuff, right? So lists allow members of a list to be of different types. They don't have to be uniform. They don't have to be homogeneous. Now, lists are really cool and they work really nicely with iterators. So we covered iterators a few lectures back. They are just simply like automatic for loops that go through a collection or a list, something that is iterable. So I just want to do a quick list review before we really start, going into 2D lists, what exactly they are and such. Okay, so we're going to do a little bit of a code example with lists just to review again and to really solidify what a list is so that we can move forward with today's lecture. Alright, so today I'm going to be using Visual Studio Code to do all of the lecture coding. So let's start by making an empty list. Let's call it my list, and it's just an empty list. And if we were to print this list out, it would just be an empty list. So see, it's just an empty list. Now if we want to add stuff to this list, we can do append. Let's do that. Let's just put a 1 in there and see what that looks like. See, now I have a 1. Now let's append a 2. And I have 1, 2. Now let's append true. That's a boolean type. Yep, and now let's append, let's do pi 3.14. And there it is. Now let's say I want to change that 2 to something else. Well, we can use the indices to modify them. So we can do my list, then index of 1, and let's change this to -9. So we do that. It's easily updated, and we can also do the cool stuff we would do with those interesting list function. Like we could do stuff like pop to delete the latest the item that was last submitted into the list, last appended, and it removes it. And we can do a bunch of really interesting stuff here. We can also create a list with pre filled in fields. We can do 1, 2, 3, and then we could do a let's do a string in there as well, hello, and then let's end it up with a false. And then if we were to go to print that out, it would print out just fine. Now this was just a quick refresher about what a list is, what they look like, mechanically how they work. I know you guys already know this. I just wanted to go through it really quickly in case some of the finer details, like the nuance of lists, might have slipped your mind for a second. Alright, so we just finished up our list review, and now we have a good idea what lists are. Everything's fresh in our minds again. And I want you to think about 2 facts about lists. So first, lists are a collection of objects, and then only objects can be on this list. Now I want you to think about a fact of Python. Everything in Python is an object. Every number, every string, every boolean, everything is an object. Therefore, lists are objects. Now I want you to think about that for a second, because that's going to lead us to a really fundamental question that is going to be the topic of this lecture. And the question is, can a list be placed inside of a list? Because we said that a list is a collection of objects. And we said that everything in Python, every piece of data at least, is an object. Therefore, lists are objects, and I just said that lists are collections of objects. So does this mean that we can indeed put a list inside of another list? Would this work? So again, think about that for a quick second. So the answer to that question is yes, you can indeed put a list inside of another list. These are called 2D lists or 2D arrays. Lists and arrays they pretty much mean the exact same thing. In Python, you almost always refer to them as lists. In other languages, you'll probably refer to them as arrays, but they essentially mean the same thing. So a 2D list in Python is just a list that, as its members, contains lists. So you can think of that. You can think of it as a list within a list, or a list of lists. That's all a 2D list is. So on screen we have a little diagram that showcases what a list looks like its structure. Let me get the laser pointer. So we have an array, which is a list, and then every single space in that list corresponds to an index. So this list at index 2 has value of false, and this list at index 4 has value of 3.14. Now, this list goes up to index 4 because there's only 5 objects in this list. If we were to try to access anything beyond 4, the program may crash, we'll run into errors, and you're not supposed to do that. Now this list can be increased. We can append to it, we can add more elements to it, and then we will be able to access indices beyond 4 and 5. But this is generally what we think of when we think of a list. We think of a collection of objects, and each of these objects are ordered in such a way that we can access them directly by their indices. So when we first put an A into this list, it's going to be assigned index 0, and then when we put in 2, it's going to be assigned index 1. And then we can directly access these two members using the index 0 and 1. Now, keep this in mind, because now we're going to look at what a structure looks like for a 2D list. So you have a 2D list on screen, and now it looks a lot scarier than the 1D list, but it's essentially the same thing. See, let me get the laser pointer out again. We have our list here, but then every single value is another list. So let me start circling stuff. So this whole thing is going to be our index 0 now, and this whole thing is going to be our index 1. This whole thing is going to be our index 2. Then this whole thing is going to be our index 3, and then this is going to be our index 4. And then within those lists, then there's even more indices. So then this is going to be index 0, 1, 2, 3 for this list, and then this is going to be index 0, 1, 2, 3 for this list, and so on and so forth. So it's not really that different from the previous slide. We still have an initial list. We have, index 0, 1, 2, 3, 4, but now we have a list within that value. So earlier, index 0 just pointed to a single object, but now index 0 points to a whole nother list, which also has an index 0, 1, 2, 3, and then index 1 points to the second object in the list, which happens to be another list with its own indices, and so on and so forth. This will make a lot more sense as we start doing code examples, but I really want you to keep this general format and structure in mind as we keep talking about these 2D lists. So in order to start working with 2D lists, we need to start talking mechanically about how to really work with 2D lists, so to speak, how to code these up. Now, to create a 2D list, it's very similar to the way we create a 1D list. On screen, I show you the creation of two 2D lists. The first line of code shows you how to create an empty 2D list. Now, that's kind of useless, to be honest. There aren't many cases where you're going to be creating an empty 2D list. You're more likely to create an empty 1D list and then start appending entire lists to the 1D list. But still, this would be how you create it. Now the second line of code is a more common line of code. Here we're hard coding in a 2D list that has two lists inside. The first list being a 1 and a 2, and then the second list being a 3 and a 4. That's a more common way of creating 2D lists. Now, you can append to 2D lists, of course, and you can modify individual values in a 2D list. But this is simply how you would create one, how you would start off with one. So now I have to talk about how we would access individual members in a 2D list. So if you want to access a specific element in a 2D list, so let's go back a couple slides. So here, let's say we want to access this specific element here. Well, we would have to know which list we want to go into. So in this case, we want to go into list 3 at index 3. And then we have to say, okay, which index inside of that list do we want to look at? In this case, we would look at index 2. So we would go down to list 3 and then index 2. And the way we would access it in terms of code is just like if we were accessing a 1D list. So going forward, we would just type in the name of the list. You would say which list we want to go into, and then which element we want to go into. So going back to that one, let's say you want to, again, go into -3. We want to go into this list here. This list is index 3. So which list would be equal to 3? And then which element we want to go into is this one. Now if we go into list 3, the element we want is this one, which is at index 2 for that list. So really we want to go into 3 and then 2. So which list in this case would be 3, and then which element would be 2? That's essentially how you access individual members in a 2D list. Now, all of the other list functions for looking up elements still work, but if you just want to access an individual member directly very easily, either to update it or to just use it somewhere, you can just use this method, which this will never fail you. So another way of thinking about 2D lists or 2D arrays is to think about them like matrices. Instead of thinking about them as a list of lists, if for some reason that's you're not really understanding it well that way, don't think about it as a list of lists then. Think about it as a matrix with coordinates. So let's say I want to access this element here. So what we would do is we would first go from left to right until we get to that column. So to get to this one, we start here, and then we keep going to here, and then we keep going here, we keep going until we reach the column. Now to reach that column, we have to go to index 4. So what this number says is how many times we have to move to the right. So once we have that number, we have to figure out how many times we have to go down. So once we're here, this number is not what we're looking for, so we have to go down once. And now now we're there. So the coordinates would be 4, 1. And the way we would access it would just be, my array for 1. And now we're in A. Now we can override A, or we can use it for calculation, we can get it, we can do whatever we want now. But that's generally how it works. Now let's say we want to access, this one. So to do that, again, we have to first figure out from left to right how far we have to go, then from top to bottom how far we have to go. So if we start on the top left, we have to go over once, and then we're there in terms of, left to right. And then we have to go down once again, and we're there. So to access that one, we have to go to my array 1, 1. Pretty easy. Now let's say we want to access this specific one here. Now we go from left to right, and we're there already. We don't have to move at all, so we don't even move. So the first number is going to be 0, and then we have to move 1 and then 2, and we're there. So 2. So then we have to go to my array 0, 2. So if the way we were talking about earlier wasn't really making a lot of sense, you can think about it like this, where the first number is how many times you have to move from left to right, and then the second number is how many times you have to move from top to bottom. You can think about them as coordinates, so to speak. Okay, so what if we want to add to an existing list? Like earlier we mentioned how to create an empty 2D list, but what if we want to add to an existing 2D list? Well, a very simple way of doing it is just doing append. Regularly, when we do append, we just put a single value in there, whether it be a number or a string or a boolean. But if it's a 2D list, you have to add a list, right? Like on screen. So now we're doing double list dot append and then a whole nother list, and that's going to be added to the end of double list. That's just one way of doing it. There's other ways you could do it, but this is honestly the most simple way to do it. Alright, so now we're gonna look at some code, just work through a couple of problems in Visual Studio Code, just so you guys can get a better feel for 2D lists, because the best way to understand 2D lists is to see them in action and then to use them yourself. So I highly encourage you to code along and change these examples, play around with them a little bit, just to get a better understanding of how 2D lists really work. Alright, so first let's start off by making an empty list. This is what you should ideally be doing when you want to start off with, to add stuff procedurally to a 2D list. So let's just start with an empty list. And let's print that out so we can see that it's empty. Okay, there we go. So yeah, it's an empty list. Now let's add a list to that list. Let's do append, and then let's add 1, 2, 3. And then print it out. And there it is. We have a 2D list. And you know you have a 2D list when you have the square bracket and then another square bracket inside. Now let's add another entry to that 2D list. Let's do 4, 5, 6. See, now we have 2 lists inside this, big list. Let's keep adding a couple more entries. Let's do append 7, 8, 9. And then let's do append, let's do A, B, and then C. Let's run it again. So yeah, like was previously discussed, the lists don't have to be homogeneous. They can contain different types of data. Here we have a uniform integer list, and here we have a uniform char list. See, they can have all sorts of different types. They don't have to be uniform. And then that goes, again, for the list within. Now, the thing is, the problem with this is that this representation does not really look that nice, right? It looks kind of weird. The problem is when you use the built-in print function for Python, this is just how it prints out list. So let's make our own print function. Let's do print double list. Let's just call it like that, and let's say we're giving it my list. And then what we're going to do is we're going to do for x in my list. Now this function, the point of it, it's just going to print out 2D lists in matrix format. When I say matrix format, I mean in the format we saw earlier in the slides. So now, let's think about this for a second. What should be the next line? Because for x in my list, well, that's just going to iterate through the list, right? And if we iterate through a list, through this list specifically, what's going to happen is I'm going to start here. That's going to be our first x. And then once we're done with that iteration, x is going to become this. So x is going to be an entire list throughout each of these iterations. So what we're going to have to do then is use another for loop for y in x. This looks a bit weird, but trust me, it's going to work. It's going to be pretty cool. So if we do, let's say, str of y, and then we do let's see, we could do comma and equals, then yeah, that should work. And then we do print, and then just print out an end line, just a little, an empty string. Let's see if this works. Let's call this function now and see what happens if we call it with with my list. All right, let's see. Oh, I didn't do the define. Let's try it now. See, that's much nicer. They're all grouped up together, but let's just fix that by adding a little space. See, now it's looking like the representation we saw earlier. And you can use this print statement to figure out where each member is and how to get the indices for it. Now, let's change this code a little bit so it's a bit more friendly. So instead of saying X and Y, we could say, we could do column, for example, or row, or list. Let's do current list, because remember, this iterates across the whole lists. And then instead of X, now we do current elements. So let's change that. It should work just the same. I just changed the variable names to be a bit more descriptive. And that works just fine. Now, again, the reason we do this is because if we look at the built-in print, it's not as nice, it's not as easy to understand what's going on. Now, let's say we wanted to make a list that started off with all the values we wanted. So here we kind of added to it. What if we want to make the list from scratch? So the way you do it would be, let's call this my new 2D list. So first you have to start off with the little square brackets that says, okay, this is a list. And then you have to start, doing lists inside it. So let's do 1, 2, 3, and then let's do A2, and then pi, and then let's do we could also do false, true, 0, 1, 2, 3. Also, lists don't have to be all the same size. You can have lists within a list of varying size. Now, you should stick to rectangular shapes where all of the rows and columns are relatively of equal length, so all columns are of the same length and all rows are of the same length. You don't have to make sure that rows and columns are of the same length, but I would make sure that all of my rows are the same length and all of my columns are the same length, because it just makes it a little bit easier when you want to do some advanced computation. But this works just fine. Like, if we make it, it'll work just fine, and even the function we just wrote should work just fine. So let's test it. Let's call this function with this. Yeah, it works just fine. So the first list was 1, 2, 3, and then the second list was A2 3.14, and then the next list over was false, true, 0, 1, 2, 4.15. Now, as you can see, me having like uneven lists didn't matter. It'll work just fine. And you can have as uneven lists as you want. Now, I would stick to rectangular list where all rows are the same length and all columns are the same length, because it just makes it a bit easier if you want to do some really specific calculations. Now let me change this back to 3, and I think we're gonna end up with a square. Let me see. Yep, we end up with a square. Let me comment this out. Yeah, so let's say we want to change this number to a -1. So the way we would do that would just be by going in and doing the little indices thing we talked about. So if we look at it, we have to go down to, let's see, to the second list, because we have to go down to, again, to this one. That's our second list, so we have to go to 0, 1, and then within that list, so let me write down the 1 first, and then within that list, we're going to go 0, 1, 2. So it'd be 2. And then let's set that to -1, and let's see what happens. And see, it's -1. Now, You got to be careful, because if you were to use this printout to find this indices, you have to be careful in terms of what you're seeing, because like I said earlier, the first number says which list you're looking at. Now the way we're printing it out, we're printing the whole list here, so it's kind of flipped on its side. So now the first number says how many times we're going down, and then the second number says how many times we're going to the right. So you have to be mindful of how you're printing it and which format you're following. This first number says how many lists we're going down, and this second number says how many elements inside of that list are we going in. If you were to have used that to directly here, it wouldn't have worked. So you have to be mindful of that. Like let me check something. It might work, because that was so let's see, 0 2. So 0 2 I mean 2 0 should be 0 1 2 and then 0 here. False. Let's see what happens if we run it. Let's see if it'll work. It might work. Okay, yeah, so that it does work. Now the thing is, based on what we did earlier, this is kind of flipped on its side. So you have to keep in mind how you're printing it out if you want to base it off the printed matrix form. It's better to just think about it like this, you know. First number says which list, and then second number says which element in that list. Now the way I prefer to print out, to type up my my list, is like this. To me, it just makes a bit more sense than the other way. I can more easily see the different lists and what's inside of them, and this should work just fine. See, it just works. It works just fine, but it's a bit more in terms of code, you know, space consuming. But for me, it's honest. I think it's worth it, because it just makes it a lot more easier to see what's going on. Now let's do a quick example. Now let's say we wanted to make an array or a 2D list that kept track of students and their homework grades. So let's make a 2D list. Let's call it student records. And it's going to be a list. Now, when we add to the student records list, what we're going to have to add, we're going to want to add the name of the student. Let's call him Jan. And then the grades. So let's say he got a 100, a 90, an 80, and then a 100. And then let's say there's another student, and that student got a let's say he got a, oh, see, I forgot to put the list in there. There we go. That's much better. So let's say we have another student. Let's name him Tyler. Now let's say that Tyler got all 100s except on the last assignment where he got a 70. Now let's add another student. Let's call this student, let's call him John. And let's say he got an 80, 90, 100, then an 80. Okay. Now we can print it out using this print double list function. So let's try that out. Let's see how that looks like. And let's comment this out. And yeah, it looks really nice. Now, the thing is, maybe I want a program or a function that takes all my student records and then calculates what their current grade is. So that's definitely something we could do. In fact, we can start off with print double list and just modify it. So let's do that. So if we do that, we do, let's call it calculate grades. And now let's say that this class only has 4 assignments, so we know that as a fact. And then let's just call this given list, just to make it a bit easier. Or actually, let's just call it my list. Now, things are a little bit different now, because now, since we're getting the student records, we can change this to be a bit more descriptive. We can call this student record, individual, single. And then once we're in the student record, we're gonna um, see the fields in that student record. So let's call it fields in student record. Now, the first field of that student record is going to be the name of the student, right? So let's do something like this. Let's say I equals 0. And then if I equals 0, then we know we're in the first field. So let's print out the name of the student, right? So let's do str fields. And then let's do a little plus, well, not a plus, a colon. And then that's gonna, let's do end equals just nothing. That should be fine. Now, after that, let's set I to 1 so that we don't go into this again. And then for all of the other ones, what we're going to do is we're going to, let's say our grade is 0. Actually, we don't even need to do that. We can just do this. Now what we do is just, let's do an else. What we would do is just grades is going to equal, no, yeah, we do actually need to do grades equals 0. So what we do is grades plus equals, let's do fields plus grades. So it starts 0, but then we slowly start adding the grades for it. Now, once we're done with that, what we're going to want to do is we are going to want to exit out of here. So for our first iteration, which is going to be the first, and for the first entry in that list, it's going to be Jan, Tyler, or John. So that's just a name. So that's why we have this. We just want to print the name. Then for every other one, we're going to be adding the number to grades. Now, when that's done, once we're done checking through this whole thing, what we want to do now is we want to print out their grade. So now their grade is going to be, let's do final grade is going to equal grades divided by 4. And let's do that. And then, yeah, it should be good. Let's try this. And then let's multiply that by, oh, this should be by, how much is it? So it's going to be 400. And then we multiply that by 100 for the percentage. So then all we have to do is we print out the grade, which is going to be str final grade, and then we do just a little percentage sign. Now let's see if this works. I'll be very surprised if it works, because I'm coding this up kind of live while we speak. So let's see if this works. Let's see. All right. Oh, yeah, it works perfectly. Now let's see. Let's see. We have 100, 100, and then 90, 80. Let me see. Yeah, that should be about 92.5. Then this is going to be equivalent. And then, yeah, so that's pretty straightforward. So this is a use case in which and how you can use 2D lists to really implement really cool logic here. So I kind of made like a grade calculator here. This could be a lot more advanced. In fact, we could make a function where you input the grades to a bunch of assignments and then you run the calculate grades function. 2D lists really allow you to implement really cool and complex logic in a really condensed way because they kind of incorporate some of the complex logic into its structure. Let's add a couple more so we can see. So let's see. We have 100 and then we get a 0. And then we get 100 and then another 0 at the end. That should be an average of 50%, I believe. Let's call this guy Rick. Let's take out John from there, and then let's try it. Let's see. Yeah, so it's working properly. And then in fact, beyond this, you could add an if statement that calculates what the letter grade is, whether or not they pass, give them a cool little message that says, hey, you passed. In fact, let's do that right now. Let's do end equals that. And remember, I'm doing that end thing so that a new line isn't added. So let's do if final grade is less than 70, we print out failed the course. Otherwise, print out pass the course. Let's put a sad face here, and then let's put a happy face here. Now I'm adding the space here so it won't be right next to the percentage sign. And in fact, we could make this a lot prettier. Like we could do this. This will make it a lot prettier. This will add a tab after the percentage sign. And in fact, we can add a tab right before we print out the grade as well to make it look a bit nicer too. Let's see how that's looking. Yeah, so see, this looks a lot nicer now. So everybody passed except Rick, which failed miserably. But this is, again, this just shows how nice 2D lists are. We could have made again a function where we populate these fields, these grades, and then rerun the calculation. Now, what I would suggest you do as an exercise, try to do that. Try to make a function that asks the user for a name and then for all the grades, and then add it to student records. In fact, you can add a little menu for like a teacher where they could press option 1 to add a student, option 2 to print out grades. You can even add another option if you really want to challenge yourself, where you make the teacher select which student they want to modify a grade for. That'll be a really interesting use of 2D lists, and it'll really test your 2D list knowledge. If you can do that, you are ready to use 2D lists in any of your programs. So we've been talking a lot about 2D lists, but what about 3D, 4D, 5D lists? Are these a thing? Well, in Python they are. Python allows for n-dimensional lists, which means that as many as you want. So 1D lists have been normally lists of objects, you know, a list that has 1, 2, 3. That's pretty straightforward. Then 2D lists are a list of lists. Again, a bit trickier, but still pretty straightforward. However, you can have 3D lists, which are a list of lists of lists. So far in 2D lists, we saw that in each, when you have a 2D list, each index of the first layer is a list, and then each index of the second layer is your final value. Well, in a 3D list, it goes a layer deeper. Every index of your first layer is a list, and then every index of your second layer is also a list. And then once you get to your third layer, that is where you have your elements. And you can go as deep as you want. Now, it's hard for us as humans to understand how a 4D, 5D list looks like, because we live in a 3D world. You could argue that we live in a 4D world where the fourth dimension is time, but spatially, it's a 3D world. You know, we have height, depth, and width. That's pretty easy to imagine. You can kind of visualize a fourth dimension if you have all that next to each other, but then trying to imagine a fifth dimension is kind of impossible for us as human beings. However, computers, they really don't care about any of that. They can represent all of these kinds of things without any issue at all. At that point, the programmer is the limiting factor. Now, usually you won't go past a 2D list, and unless you're doing some advanced mathematical proofs or some advanced mathematical computation, you won't go past 3D lists. Even then, 4D, 5D lists are so absurdly rare that if you're thinking that your solution may need it, you probably don't. Take a step back, really think it through, because there might be an easier way to implement it. And I would still tell you to do that if you think your solution might need a 3D list. Anything beyond 2D might be unneeded for like 99% of things. Now, for a 3D list, that might be useful in case you want to represent a 3D space. You know, maybe you want to represent a map with heights, a topographical map. That could be useful for a 3D list, but I can't even think about something that might be useful for a 4D list or a 5D list. Maybe across time for 4D lists, but I have no idea what you would use a 5D list for. But it's just very important to know that Python allows for n-dimensional lists. Now, you can't have a 0-dimension list, and that's not really a thing. But you can have a 10D list, an 11D list, and they work the exact same way. You know, a list of list of list of list. That's really all it boils down to. So a really important point I want to make sure gets covered is that all of the list functions that we've learned in the list video work with 2D list. Remember, a list is just a collection of objects, right? So all of those functions that we talked about earlier, they still work. They still function as intended, and you could still use them with 2D list. You know, a 2D list isn't suddenly any less useful because it's got somewhat more complex. At the end of the day, there's a 2D list is still just a list of objects. It just so happens that the object that we're storing is another list. But all the functions that we saw for lists still work just fine, no issues. So to wrap up this video, there's really two things you need to keep in mind. 2D lists, they're just regular lists whose members happen to also be lists. They are a list of lists. This, 40-something minute video could be compressed into that single sentence. A 2D list is a list of lists. Now, a 2D list allows you to, make complex algorithms in a really simple and straightforward way. Like we saw earlier in that student record example, it was really easy to add records and to create a really neat function that calculates your grades. If we didn't have 2D lists, we would have to have several separate lists for names and then for assignments, and it would get pretty messy pretty quickly. But with 2D lists, we can condense all those different lists into just one big one. So that's really the gist of 2D lists. If you guys have any questions, please don't hesitate to email us, and good luck and stay safe.